you can find elevators that are currently in use today, elevator motors that are 50 years old. Okay, if you don't abuse electric motor, the windings, the coils can last up to 50 years. But that's not the case in electric vehicles. Electric vehicles are using motors, and those motors are they're made to perform. They're going to be made to perform, and so a lot of the electric motors that are in electric vehicles right now are water cooled, and they're water cooled because the motors get really hot, and it's the heat that basically melts the enamel that's on the windings. There's a thin film of enamel on the wire that insulates it from the other wires. If that gets scratched or melted or whatever, then that entire motor basically has to be rewound. And the nice aspect of the RegenX motor, once it's in electric vehicles, if one of the coils overheats or gets damaged, pull it out, put another one in. It's there. And again, if it's a machine that's on the floor of a conveyor belt system that that's running 24 hours or whatever, the last thing you want is for your motor to break down, and then you have to shut down your production system. This allows for a technician to go in and change the coils as needed. And anything else?
So part of this is patented, right?
We have 3 patents issued.
Yeah, I'll just be, to get into technical, I'll just be interested in what you've been able to do to protect this technology, right?
We have 3 U.S. patents issued. Okay. We have 2 more pending, at least 2 more, and the motor patent. The motor patent is the latest one, latest patent that was issued, and it has what's called a publication ban on it. So that means that when you file a patent, the public can see the patent online.
Right.
The RegenX motor will never go online. Like it's a private. It's a secret patent. So with regards to protecting it, the RegenX motor patent, it would only be available to people like whoever's making the motors. And
so you control the access to it, basically. Okay.
Yeah.
That was one of my questions, because if
for
there's enough people out there that if they can figure they can make it work, they've got enough money that you can never chase them down hard enough to get right.
Yeah,
I'm just saying, let's say Elon Musk decides that he wants to do this, right? Yeah. If he has access to the drawings, he can probably outrun all of us legally, right? Yeah. And do an end run, and then has the technology without actually really paying for it. Yeah. Or it takes him 20 years till he finally fights it out. Right?
Yeah. So the first stage of technology commercialization for us is basically to file patents in essentially every country on the planet. And we have the patents in the U.S. basically cover what's called patent treaty countries, so Canada, UK, right. They're all covered.
Most of the West is covered in that.
Yeah, and then you have to file patents in India and China and so on and so on. But the advantage of the technology from a patent standpoint is that, again, if you don't have to increase the mechanical power in the drive shaft. When the generator is placed on load and it's delivering output power, if you don't have to increase the mechanical power in the drive shaft, that generator is operating at infinite efficiency. Okay, so here's how it works. If this generator is idling at rotational equilibrium, okay, and we take 9 watts from the generator and deliver 9 watts to the load, if the mechanical power in the drive shaft increases by 10 watts, that generator is 9 output divided by input. 9 divided by 10, 9 divided by 10 times 100 is 90% efficient, okay? It's 90% efficient at converting the mechanical input power to electrical output power, okay? If the mechanical input power doesn't increase, if it stays at its idle level of 0 watts, then it's 9 divided by 0, that's infinite efficiency. So the advantage that the technology has over everybody that would want to copy it is that they would have to be willing, those engineers, that's why I asked, are you a mechanical engineer, are you an electrical engineer? Because most mechanical engineers, most electrical engineers, they won't be able to accept something that operates at infinite efficiency. Or they wouldn't even be able to accept something that operates at over 100% efficiency. So the message that this new innovation puts out there is so far beyond what the average engineer is willing to accept that they just dismiss it. So Dr. Saab, when he came the other day, we went through the entire demonstration, and then I went to the explanation. Okay, I went to the full explanation of why the technology does what it does. And I did that for his sake, so that he would have a firm grasp of not only the why is it doing what it's doing, but how is that possible? And then when you have that, if you're an engineer, if you have all that information, you put all that together, then you can say, okay, I can get it. I can see why this works. That's not the type of demo that I'm doing for you guys here today. But to answer your question, and this is the overview of the innovation that I want you to understand before you leave, is that this innovation basically it's going to change everything. And what I think is your company's primary role is not to think that you're going to supply generators and motors to everybody on the planet or whatever, because that's not going to happen. As soon as this knowledge gets out into the general public, what I envision happening is that if you guys set up a manufacturing template and you manufacture X number of working prototypes that are completely finished products, rather than just demonstration prototypes, and you set up the manufacturing template, and you develop some of the scale-up parameters that are required. Let's say 1 kilowatt generator, 5 kilowatt, 10 kilowatt, and you get all that stuff ready. Eventually, the GEs of the world, the Westinghouse, ABB, Siemens, all those guys are going to eventually come and knock on the door, and they're going to want to be able to acquire the knowledge that you've developed and take it and apply it in their whatever. And there's potential there, rather than wanting to supply generators here, there, and everywhere, but to supply the components that Siemens would need to go to market right away. The coils are done, the magnets are done, the rotors are essentially done, the housing, all that stuff. To me, the best advantage for you guys is to say when Siemens comes, whoever it is, they're going to come and they're going to want to know how to do it, and you say, this is how you do it, and by the way, we can supply all these parts so you can hit the ground running. That's where I see the best advantage for you guys. Because like you say, when Elon Musk finds out about it, and yada yada, and Elon Musk already knows about it. And Nissan, Renault, Mitsubishi contacted me just last week. So the knowledge is getting out there, the information is getting out there. We're talking to Tata Motors in India. So the idea for me, for you guys, is that you develop the components and the know-how and all the various components, and then when these guys come knocking on your door, you say, here's how you do it, and by the way, if you want to buy the parts, you can. If you want to make them yourself, you can. But if you're going to make them yourself, that's lead time. Why not just buy from us? And that's how I see it. You guys, you guys can do whatever
so
you
want.
want.
To license the manufacturing is what you're saying, right? Is that?
Yeah.
So it would be making the housing and making...
Whatever way we really want to do it, right? So
yeah.
You say you get the product commercialized, right?
Get the product
to
developed.
To a commercial level, right?
Yeah, get it developed.
Yeah.
And during that time, Paul and Dr. Sab and these other guys and the PhDs in India and the companies in India, they're going to eventually come up to speed. The idea would be that the ideal idea would be that by the time the automotive companies and then whoever, the generator companies, get fully up to speed, you guys are fully up to speed with the development, so that when they come knocking on the door, you say, come on in, this is how you do it. By the way, do you need a housing because it's specific? Do you need a rotor because it's specific? And yada, yada, yada. And then, and hopefully they would say, well, yes, we want it because we want to get to market before our competitors do, so give us what you got. And then you can either supply components or full generators, and certainly you would be supplying the technological know-how, because they don't have that. They have to get it somewhere. So they buy a license from us, and they commission you guys to teach their engineers how to put it together.
Right, and so we can do that in a way that protects us to keep residual.
Yeah.
What I'm saying is, because I'm assuming what you're looking for is a residual source of
we're
revenue from the technology that you developed.
We're going to license, yeah.
Right.
We are.
And I think we'd like to see something, if you can hitch your wagon to it at a small stage. It's nice if you can grow and scale what we develop at the same pace as
you guys. If you guys can add value to their, who knows? Somebody might say, no, we're going to manufacture our own. And you say, okay, but in the meantime, buy from us until you get your setup done, and then when your setup's done, then you can keep buying housings from us, or you can make your own, but you've generated revenue in the meantime. And that applies to every generator and motor manufacturer on the planet, and every electric vehicle company as well.
So in a hypothetical situation, let's say let's say it takes 6 to 12 months to develop the process.
The first one, yeah.
So let's say it takes a year to perfect it, right?
Yeah.
What happens if 9 months into this process, XYZ company comes and has the manufacturer? What I'm saying is they can throw 10,000 engineers at it if they want to, right?
Yeah.
And suddenly they go, you know, they do an end run around. So now we've just developed they can do it in 3 months, that we did it in 9 months. And then is there a way to protect ourselves during that time? Not to stifle it, you know what I'm saying?
Yeah.
I'm not trying to stifle it, but is there a way to make sure that we are protected
Yeah,
for
well,
that
we could
manufacturing license,
Well,
right?
okay, so there are ways to make the technology better. So right now we're using permanent magnets on the rotor. Okay, so if we continue the R&D, part of the R&D process is to replace permanent magnets on the rotors with electromagnets. Okay, so the disadvantage with permanent magnets, an electromagnet is basically a coil. Okay, so the magnet on the rotor would be placed with a coil. The nice part about that, and this is where we could do an exclusive R&D thing with you guys, is the nice part about replacing the magnet on the rotor is with electromagnets is you can vary the strength of the magnetic field. Okay, so if you have a coil, by varying the electrical input to the coil, you vary its magnetic field strength. By varying the magnetic field strength, you vary the output of the coil, like directly. So that's something that needs to be done. And then there's the development of the motor circuit. And if we were to do something together, we would have to, you guys would have to be involved in the R&D process so that would keep everybody having to come back.
Right. Because what you want to do is create something,
Yeah.
without stifling the spread of the technology, you do want to create something that rewards you and rewards whoever's involved in the process, I think, right, to be honest. You know.
And what is eventually going to happen, the way I see it, is basically every electric motor company on the planet is going to have to come to your facility to learn how to make these motors and generators.
Right, so what we could do is, I guess that's where we could put a mechanism in place where they're basically licensing a sub-manufacturing component, right? Or what I'm saying is now you are able to take this technology, we can teach you how to do this.
Yeah.
You can take this technology and apply it, but there's like a residual royalty of some sort by you manufacturing off-site, right? So it doesn't really matter, either we can manufacture for you or you take the technology.
So we sell a license to GE to manufacture. Part of that license obviously requires them to go and see you guys to learn how to make the generator.
So we're selling them IP, right? That's intellectual property.
Yeah, so they would pay you to teach them how to learn how to make them, and then you can supply the housings, the rotors, whatever. You can develop. You have enough lead time that you can develop the systems that get them to market as quickly as possible, rather than them having to start at square one. That's where your value add to
right,
them
the springboard.
Yeah.
And have you done anything in China at all with patents?
No.
The reason I'm saying is because they're obviously they don't innovate, they imitate, right? Typically.
India is the same way.
Okay.
Yeah, and they're encouraged to do that.
I'm just saying that's a fact status quo right now, right?
Yeah.
So you see technology here, they look at it, disassemble it, and then find a way to do it.
Yeah. But part of this innovation, the major part of this innovation is, in order to accept this innovation, you have to be willing to accept the new laws of physics that go along with it.
Okay.
So, if you're willing to just jump in and say, I accept what I see, let's go for it, you're off to the races. If your engineers are like, No, I don't think so, and whatever, that slows them down, and that's to their detriment. You can't, that's just human nature, you can't do anything about that.
I mean, if it works, it works, right?
Yeah.
So I know,
Again,
you had MIT here, right? I was looking up, there was a little bit of history with.
We went to MIT
Okay.
and demonstrated to
Yeah.
them. They basically said, get the hell out of here. We spent 2.5 years at Ottawa U, and it's challenging, okay? It's not the easiest thing for an engineer to accept. Dr. Saab, who's a PhD mechanical engineer, was willing to accept the explanation because he's working for Lebanon, and Lebanon is desperate.
Yeah.
Okay, they need a solution, and this is the solution. So he came in with an open mind.
So it's preconceived,
It's
trained, if you want.
the educational system
Yeah.
says right now that everything that you just saw is completely impossible. But it's impossible until you understand the load current delay. Once you're willing to accept that that's possible, then that's the basis that explains to an engineer why it's doing what it's doing. It would just bore you guys,
Sure.
but an engineer would say, I need to know exactly why it's doing what it's doing, and that's fair, and that's part of the demo that we do for an engineer.
Mm-hmm.
And then there's the explanation of, well, why does it do what it's doing above 30 kilometers an hour and then it doesn't do it below? That's another part of the explanation that you have to give to an engineer.
Is that kilometers or is that just your RPM?
It's the operational frequency of the coil. Okay, so if you take a RegenX coil and you operate it at a frequency that's above what's called the critical minimum frequency for the coil, the critical minimum frequency for the coil dictates whether the coil is going to operate like a conventional coil and produce deceleration of the system, or like a regenerative acceleration coil and produce acceleration. So the critical minimum frequency of operation dictates that. If it's above, you're in regenerative acceleration mode. If you're below, you're in regenerative braking mode. So, and that part of the explanation, changing the frequency of operation, is where an electrical engineer who's educated enough will say, oh, I get it. I get that, I understand that, and then I understand that, and then I can understand it's like, again, the demo that we did for Dr. Saab was a 2-hour demo, and most of it was technical, because by the time he left, I wanted him to know not only that it was real, but why it's real. And so that's eventually, you guys, eventually, as I see it,